The broadcast is now starting. All attendees are in listen-only mode.
Okay, go.
Okay. Hello, everybody. I thought this is also interesting. Can you guys hear me? Is
Yeah,
there any way to...
we can hear you fine. Everybody is muted, so go ahead.
Okay. But Bill, as I said, they can also...
Okay, okay, go ahead. Kamal? Kamal, you might try unmuting yourself if you muted yourself. Kamal, can you hear me?
Yes.
Okay, go ahead.
Can you hear me?
Yeah, we can hear you. Go ahead.
So again, sorry for the technological issue. Again, let me introduce myself again. So my name is Kamal Hossain. I'm an assistant professor in the Department of Civil Engineering in Memorial University in Newfoundland. So I'll be talking about the application guideline for how to optimally de-ice and anti-ice in our road and parking lot and sidewalk in this session. So throughout this session, I'll follow this guideline. First of all, I'll talk a little bit about myself, and then I'll introduce the topic, basic information on de-icing and anti-icing, and how salt works. Then I will give an overview of the salt rate models from the literature. And then I will talk about some application rate that has been developed for roadways, parking lot, and sidewalk. And at the end, you guys can ask me a question, or you can also ask me a question during this presentation. So I originally from Bangladesh and did my undergrad in civil from Bangladesh University. Then I did my master's, PhD, and postdoctoral research at the University of Waterloo in Canada. And then I did my postdoc at the University of Illinois in USA, all on road and pavement topics. And I also did a little bit of work in the industry, and I have been teaching some transportation courses. So for the winter road maintenance, first of all, why it is important. So just to give an idea how much our transportations are affected by the winter, just to share in statistics, in Canada, we see about 50,000 serious injuries from winter-related issues during the winter month from November to March or April. And most of them are occurred in roads and parking lot and sidewalk and cost us billions of dollars of taxpayer money for the treatment purpose. What happens basically with the snow and ice, the pavement condition, road condition become very slippery. The friction level reduce. So we want to do something on that to improve the pavement condition. And to do so, we do a lot of winter road maintenance activity. And in Canada, we spend about $1 billion for different winter road maintenance activity that we do. Again, this is estimated by federal government, and every year our Environment Canada basically reports this information. And one of the major activity we do common to other part of the world, de-icing, anti-icing, and also we do just plowing, that is mechanical snow maintenance activity. We also do some other treatment also, like using of sand, abrasive. Just to give an idea on the de-icing and anti-icing. So for the de-icing, we do apply salt after the snow event on top of snow. And for the anti-icing, we do apply salt before the snow event or at the beginning of the snow event. Both have some positive and negatives. For the de-icing, the positive side is you do not lose salt that much from the road due to traffic and wind action. And as snow is on the pavement on the road, so salt can stay longer time. It does not blow off from the pavement. But for the anti-icing, the main benefit is you can prevent the snow bonding, so plowing operation become easier. But problem with the anti-icing is if snow forecast changes, you lose the material. Also, due to the wind and traffic action, you lose some material from the road. And you can apply pre-wet salt, but still, if it doesn't help, if snow forecast change, also if it is wet snow, the dilution rate basically increase if you use anti-icing strategy to control your snow and ice. As I said, in addition to de-icing and anti-icing, people do also plowing. Some agency just plowing for certain road for low level of service road, and also in many cases people do both plowing or anti-icing or plowing de-icing or anti-icing de-icing together based on the level of service requirement. So you can see this chart I borrowed from NCHRP 526 report. This is one of the best report how to control snow and ice. So this chart shows what are the strategies you can consider depend on the level of service requirement for your facility, transportation facility, either it is low volume road or high volume road. So level of service can be based on within event, and level of service requirement can be after event. And based on that, you can design your winter maintenance strategy. Any questions so far? Okay, you guys can also chat, send your question in the chat box. I'll see and try to respond before you forget the question. So during this process, winter road maintenance process, we use huge amount of salt. Again, CESTiCC Canada report about 5 million ton salt just in Canada we use during the winter months every year. And this salt has huge impact on other part, like environmental side, on roadside vegetation, on the lakes, rivers that near to the highways. The aquatic life is affected by the chlorine concentration increased from the salt application. Also, it affects the vehicle, metal infrastructure and river in the bridge. That chlorine basically creates corrosion in this structural elements. Also, many studies report that salt has also effect on the concrete pavement, but less in the asphalt pavement. Still, it has some kind of negative impact. So we need to responsibly salt. Now, how salt works? So when we apply salt, basically it disperses into the snow and ice, and it dilutes, and it basically lowers the freezing temperature further. And based on the salt amount, it can go as long as theoretically minus 23 C in Celsius scale. But in practice, in practical world, we notice that salt works based on the snow amount minus 10 or minus 12, and based on the chemical concentration. There is a theory on that, how much salt concentration is needed. That is C, and it basically based on the eutectic temperature of that chemical or salt and the pavement temperature you are dealing with. And to better understand how salt works, how much salt needed, what are the factors affect salt? For example, the pavement type, traffic volume, the sky view condition, snow amount on the ground, snow amount in forecast, the pavement temperature, light snow versus heavy snow, how these things affect the salt performance. To understand this, we spent a lot of time during my PhD in University of Waterloo. So I spent 4 years to understand how salt works and what is the optimal application rate during the period of 2011 to 2015. So in this period of testing years, I tested about nine salt, 5 solid salt and 5 liquid salt. Of course, the main material was regular sodium chloride, and from the liquid side, main salt was brine. But we also tested other liquids. And also, as I said, we covered 3 winter, in a total about 100 snow events. And during the test, we designed our test site in a way somewhere trafficked and somewhere traffic controlled to understand if traffic has effect in salt melting. And we also covered asphalt pavement versus concrete pavement, and also pedestrian walkway we also included in our test matrix. So any questions so far? Okay. And from this experiment, from 4 years of data, we found that many factors affect the salt performance. We measured the salt performance in terms of melting rate, snow melting rate, that we collected through collecting the image of the site, the photographs we took during the snow event. We also collected the friction data on the test site using a friction meter called T2Go. And based on this performance, we basically try to understand what factors affect this performance variable, and we found treatment form for sure affect the performance. Either it is de-icing or anti-icing, the performance can significantly vary. Also, pre-whiting, if you do apply pre-white salt, yeah, performance, it affects the performance. the application rate has huge impact in the performance. Precipitation type, is it light snow or is it heavy snow? Based on that, salt performance changes. Precipitation amount, is it 1 inch snow versus 2 inch snow? The performance changes. Of course, pavement temperature affects the salt rate performance. Traffic volume, is it heavy traffic versus light traffic? We saw there is a difference between performance. Also other type, minor effect, slope of the pavement, pavement type, asphalt versus concrete. We saw that if we have concrete pavement, I remember we saw that we can reduce 10% less salt if you treat concrete pavement versus asphalt pavement. We have a document. We publish this data through different publication. At the end, if you have any, you want to know further, I can share the paper with you guys on each of the component. We have more information. So based on this data we collected and based on snow melting theory, we tried to develop a mathematical equation that can we use to quantify how much salt is needed. Again, these are based on chemistry of the salt, some fundamental property of salt like eutectic concentration and eutectic temperature of the salt you use, and how snow melting rate progress for that material, and some other variables like pavement temperature, snow density, and the friction requirement or bare pavement regain time requirement, that is indicator for level of service. So based on this whole parameters, we develop this equation where R is the application rate and T is the eutectic temperature of the salt, and C is the chemical concentration, eutectic concentration of the salt you use. T is the pavement temperature. This thing rho is the snow density. H naught is the snow depth. So I explained this parameter. BPRT is the, you can say BPRT 1, 2, 3 based on the level of service requirement for your road or the facility. And beta naught is the calibration factor that we determined from our field experiment. So if you plug in this information, you can get the application rate for your salt. So I presented this result in Utah in 2015, and it's also in that ASC conference paper. You can read. Also in my thesis, the information is available. So this is hardcore based on hardcore mechanistic empirical theory. Another equation we developed that is empirical based totally, that is based on experiment to determine the optimal application rate. So you can see this empirical equation that we developed from that study. So where application rate is function of, again, your level of service requirement, that is I'm telling BPRT, bare pavement regain time. It's an hour. Then pavement temperature, what is your pavement temperature in Celsius scale? Snow depth, how much snow is on the ground or you are expecting over the event. Snow type, that is snow density, and traffic volume. Based on this information, you can use this equation to determine the application rate needed for your event and for your road. Okay. Again, detailed information is available on this publication. I give the link so you guys can have a look later if you want to. Now, simple chart for low traffic road low volume traffic road or parking lot or sidewalk where you have less amount of traffic, you can use this chart to determine the application rate. Just one thing, as we use here in Canada, mixed kind of unit, metric and imperial. So you'll see combination of those units in this chart, but you can always convert, or I can help to convert this if you need. So what this chart talks about, if you know the snow amount on the ground, and if you know the predicted temperature in the pavement for the event, this chart will tell you how much application rate is needed for a given level of service requirement. In level of service requirement is bare pavement regain time. How long you want to allow to melt the 80% snow, basically. For example, for this case, if snow amount is about 1 centimeter and temperature is -5 degrees C of the event, and your level of service requirement is 3 hours, you want to melt 80% snow in 3 hours, you need to apply 19 pounds per square feet of salt. Okay, so I'm sorry, I forgot to give the unit of the application rate, but it's again from that paper, previous paper, TRB paper. More information is available in that paper. Okay, so this is for de-icing to melt the snow, which is mostly done in the parking lot. And in some cases, people do anti-icing also in the parking lot. So for anti-icing, we found from a survey conducted over 100 contractors, they apply different amount of salt rate, like 5 pounds per square feet, 20 pounds per square feet, even 70 pounds per square feet for anti-icing application. So we try to understand what is the minimum salt rate needed to prevent the bonding. Again, the objective of anti-icing is not melt the snow. Objective of anti-icing is to prevent the bonding, so you can easily plow off when snow stops. And we found that for parking lot or low volume traffic road, 5 pounds per square feet is enough. 1,000 square feet is enough. I'm sorry, the unit will be, all the unit will be 5 pounds per 1,000 square feet, not 5 pounds per square feet. That's too much. I'm sorry for the typos in the picture, but it's corrected in the box. So we did a huge amount of tests, and then we did the statistical analysis to understand what is the minimum salt is good enough to prevent the bonding. So for parking lot and low volume road, you can use just 5 pounds per 1,000 square feet for anti-icing operation. For the highways, again, huge amount of documents available. There is no consistent or accepted still standard across the board in US or in Canada, but still I feel like NCHRP 526 document is one of the best documents so far. It shows some systematic way of what are the application rate you can select for a given road based on the road condition, ice pavement bonding, or the temperature, and the type of road. Like if it is heavy volume road, so there is a high potential for dilution or loss of salt. So based on those parameters, this NCHRP document presents a systematic application rate that I'm sure many of you guys are aware. So if you use solid salt for temperature range 32 to 30 Fahrenheit, and if dilution potential is low, the application rate for solid salt will be 250 pounds per lane mile. Okay. For or liquid. For that scenario, this report say guides not required, mean not doesn't recommend. So again, I provided the link. I think at the reference slide, you can and this is for a table from a Finland study. Their practice is most on moisture condition on the road, then the snow condition, and based on the temperature, predicted temperature on the ground, and based on these two parameters, they recommend this kind of application rate. Again, this unit they use gram per meter square, so I did not change the unit. So to have a detailed look, make sure that you have noticed on the unit of this table. So if temperature is minus 0.5 degrees C or 31 degree Fahrenheit, and pavement or road is moist condition, the application rate will be 5 gram per meter square. But if we use pre-wet salt, you can adjust this application rate. Okay. That's all I have, and these are the references I summarized. There are many others. If you have a particular interest on anything or you want to know more, I can share those documents. Of course, you can ask me a question now. Yeah. Thank you, everybody, for listening.
Are there any questions for Dr. Hossain? I've unmuted all of you, so if you've got control of your mute button, if you would like to say something, you can either type it in or just unmute yourself and ask your question. No questions? Okay, I thank all of you for attending today. Dr. Hossain is available for you if you have any additional questions at any time. Thank you.
So, okay. Yeah, do you need my slides, Bill?
Oh, that does bring up a good point. We will be publishing this. Vicki is out on vacation for a few weeks, but as soon as she gets back, she'll post it for you.
Okay, okay. Keep me posted, okay?
Okay, we will.
And if any audience need any further information or resource, they can feel free to contact me.
Okay, thank you very much.
Okay, good. Thank you, everyone.